If you remember, in part 1, we successfully deployed Cloud APIC on Azure. You can always verify or adjust your settings by clicking on the Intent button and selecting the Cloud APIC Setup option. Let's now configure the logical network just as we know it. If you remember, our objective is to provide connectivity between web and database servers instance running on Azure, and to also provide access from the internet to the web server through SSH. In order to accomplish this, we will follow our 5 well-known steps, and we will start by creating a tenant. In our case, we will be sharing the same subscription with our infra tenant, where Cloud APIC has deployed. Remember that each tenant we create in Cloud APIC on Azure will require a different resource group. Therefore, before we start with the configuration, we will need Cloud APIC to have enough privilege over the subscription to automatically create those resource groups and configure their network. We can accomplish this through Manage or Unmanaged Identity configuration. In Manage, you just need to assign the contributor and user access administrator role to the Cloud APIC VM, and you can configure it either through the IAM GUI or through Azure Shell. On the other hand, if we go with Unmanaged, further requirements we will not cover today are needed. In our case, we will go with the Manage option using the GUI. Go to your Azure console and click on Subscription. Then select the subscription where Cloud APIC was deployed. Click on Access Control. Then at Role Assignment Classic Experience, select the role Contributor and assign access to Virtual Machine. Make the subscription where the Cloud APIC was created match what is displayed. Then select your Cloud APIC VM and save. We will now repeat the same step, assigning the Cloud APIC VM with an administrator role this time. That is it. Cloud APIC is now ready to automate the network configuration for this tenant. We will create our tenant with its VRF. Then we will associate it with a cloud context specifying UK South as its region. We will include 192.168/16 as our main CIDR block, and we will be creating 2 subnets from it, .100 and .200. Finally, we will choose VNet peering as the connectivity method for this VRF cloud context. Ready? Let's jump into the Cloud APIC then. On the left menu, go to the Application Management, Tenants, and click on Create a new tenant. You will always find a tutorial for every step we take in Cloud APIC. Feel free to read through. I will add the name for my tenant. And as we mentioned before, we will be using the same subscription for both our Cloud APIC and this tenant. Therefore, we will select Share and select our subscription. Now, Cloud APIC wants us to create the VRF. So, let's do it. I will add a name to it, and we are done. Now, the next step is to create a cloud context for our VRF. I will add a name to it, and as can you see, my tenant is already associated. So, I will go ahead and select the region. I want this context for, in our case, UK South. I will add my main CIDR block, which in this case will be 192.168.0.0/16, and then I will create the 2 subnets I want to use, .100 and .200. Finally, I will enable this VRF context to connect to other VRF through a VNet peering. And we are done. Let's now take a look at what was automatically created on the subscription. First, we can see that a resource group has been created for this tenant. If you don't see your configuration from the Cloud APIC, it means that you forgot to assign the right permissions to the Cloud APIC VM. You can also see that there is a new VNet with our VRF name and UDR routing tables for both ingress and egress traffic. Both subnets have already been associated to their corresponding routing table and network security groups. Then, if we go to the peering section, you can see the connectivity with the Overlay 1 virtual network in the infra resource group, confirming that Cloud APIC runs the VNet peering on the infra account and then automates sharing those resources with each tenant account that needs. The next step, as we know it, is to create an application profile. Simply go to your Cloud APIC and click on Application Profile and create a new app profile for your tenant. We are done. Then we need to create our EPGs. As covered before, EPGs in Cloud APIC are always microsegmented, meaning that we need to define a selector to match specific attributes in order to let Cloud APIC automate EPG assignment to each instance running on the cloud. There is no need to define bridge domains in Cloud ACI. In our case, we will create a couple of EPGs, one called Web, which will include a selector matching a tag specifying that the owner is Roxana. This means that any instance created on Azure and with a tag containing my name as owner should be automatically mapped to the Web EPG. In this case of the database EPG, we will use a similar selector matching the DBA as owner in this case. Let's go ahead and create such configuration on Cloud APIC. In the Application Management section, click on EPGs. And let's create our first EPG, which we will call Web. We will select our tenant, application profile, and our BRF. And we will assign a selector as mentioned before, matching the owner tag with my name as value. We will do the same for the database EPG now, this time with the tag matching the DBA as owner, and we are done. If we take a look at the tenant resource group on Azure Console now, we can see that the ASG were automatically created corresponding to each EPG. We will now skip the contract part and create our external EPG representing the internet to finalize our EPG configuration in our objective. Just like on-prem, remember that in Cloud ACI, we need to classify external EPGs with selector as well. So, we will create our Internet External EPG with a selector matching 0.0.0.0 for such purpose. In the EPG section, we will click on Create EPG. We will call this one Internet, associated it to our tenant and application profile. And this time, we will set the EPG type to external. We will choose our VRF and create our selector with the quad 0 value as mentioned before. And we are done. Let's now launch a couple of new virtual machines in our tenant resource group called Cloud APIC My Tenant. I will add a name to my VM. In this case, will be my web server, choosing Linux and a standard BS1LS CPU size. I will then leave the rest with the defaults, such as the username and SSH public key access. We will now click Next. Next again, and here we will make sure we have my VRF and one of the subnets from our Cloud APIC configuration selected. Since this is a web server, I will also set this VM to have a public IP. I will then hit Next twice, and in the tag section, I will add an owner tag with Roxana as its value. This way, whenever the instance is deployed, ACI will automatically match it with the selector I created before for the web EPG. Let us finalize the deployment for our web server VM. And while we wait for it to be ready, let's create the database instance now. The main difference is that I will not request a public IP address for my database server, since I don't want it to be visible for the internet. And I will set the owner tag value to DBA. After a few seconds, both instances are up and running, one with a public IP and the other one without it as expected. If we take a look at the web server instance, you can see that it got its network and application security groups automatically assigned based on the EPG selector we defined. And the same happened for the database instance. So, I would like to ask you, since the web server has a public IP, will I be able to SSH to the web server from my computer? Let us give it a shot. I will click on my web server instance, and I will try to connect through SSH. As you can see, the interface hangs. We get not reply. What is happening? Well, because as you may remember, different EPGs do not have communication by default, and we are trying to connect from the Internet External EPG to the web server EPG without a contract. Same ACI rules, right? We can confirm that no inbound rules have been defined by going to the Web Server Network Security Group, as you can see. Inbound communication is only allowed if it is come from the same EPG. So this means that instances in the same EPG or Network Security Group have communication by default, and those one in different EPGs or security groups do need a contract, just like you know it. Let it fix that now by creating a contract. In this case, we will want to allow all traffic coming from the internet to access our web server instance. Therefore, the consumer will be the internet and the provider will be the web EPG. And this configuration should result in an automating the right network security groups rules on Azure. In your Cloud APIC, go to the contract section and we will create a new contract called Internet. We will select our tenant. Since the contract will be serving this VRF only, we will keep the scope as it is and we will add the default filter which allows all traffic. Let's now apply our contract. On your top right, click on the intent icon and click on EPG communication. Let it select our contract called Internet and let it place the Internet external EPG as the consumer and the web EPG as the provider. Click on Save and let's go back to the Azure portal and try to connect to the web server again. As you can see, we now have access through SSH. If we now take another look at the web server networking security groups, we can also see that Cloud APIC automatically modified the network security group rules per our contract definition. The second question will be, will the web server be able to ping the database server? Let's try it. As we can see, the database server's private IP is 192.168.200.4. So let's open a console on the web server and try to ping it. As expected, it doesn't work, since there is no contract between the web and the database EPG yet. As you may remember, we only want to allow ICMP traffic between both and HTTP traffic from the database EPG to the web EPG. So we will create a new contract between them to finalize our configuration. Let's go back to our Cloud APIC and let's go to the contract section. Add a name to it. And we will add ICMP as filter. And we will also add the HTTP filter so that it is also part of our contract. Let's now go back to the EPG communication section and choose our contract from the previous screen, specifying the web EPG as consumer and the database EPG as provider. Let us try that ping from the web server again, and it works as expected. If you want to verify your configuration on Cloud APIC, you can go to the topology section, where you can see your tenant, VRFs, EPGs, contracts, and the related VM correctly associated to each EPG. If we go back to the Azure console on the tenant resource group, you will also see the corresponding rules automatically created based on the contracts we defined. It all seems to be working fine. Now, our objective has been met for a single tenant and VNet. However, you might be wondering, what changes if I have to communicate multiple tenant, regions, or VNets? Well, the great news is that it all stays pretty much the same. You just have to account for different CIDR blocks and subnets for each VRF or tenant and define contracts that have a tenant or global scope depending on your need. If you need a single tenant and multiple VRFs, a tenant scope contract should do. However, if you want to communicate different tenants, just build your contract in the common tenant and define its scope to be global. The rest stays exactly the same and is fully automated as well. Remember that when communicating different VRFs, Cloud ACI on Azure will leverage CSR as Network Virtual Appliance or NVAs, and each tenant's routing table will be automatically updated, pointing out to the NLB VIP as next hop. As a summary, we just learned how to deploy Cloud APIC and provide connectivity to VMs running on Azure in one VNet and region or multiple, defining our configuration once and enforcing it anywhere. Everything ACI automate is visible on Azure portal as well. This can help you reducing the learning curve and accelerating your cloud migration or integration through ACI's automation capability, normalizing security and visibility across regions and clouds.